Please be seated. Dear students, dear relatives and other supporters of the students, dear colleagues, my name is Mike de Berg and I'm professor at the Faculty of Mathematics and Computer Science. It's my pleasure to welcome you and the candidates for this graduation event. I'm happy that we can celebrate this event together on our campus. As a department, we are proud of the fact that today these students will receive the degree of Master of Science. This has been the result of hard work and actually for a number of you also for at least a part of the work. This was under difficult conditions due to the COVID pandemic, but nevertheless you managed to continue your studies and with success, and now you're here, so you can be proud of that. We offered our students a rich variety of high-level courses given by our very strong teachers, and of course a challenging graduation project which you finished successfully. These ingredients have prepared you for your future careers, and I hope, dear candidates, that you enjoyed our university, our courses, and your master thesis project. Okay. The examination committee for embedded systems has assessed the work of the following candidates: Omar Yildiz, Ragav Yadav, Siva Kanesh Teja Ganti, Karoli Toth, André Vaassen, Voetran, Ivon Turasov, Sander Steegs, and Arjon Aerts. And the examination committee for computer science and engineering has assessed the work of Filip Zamfirov, and the examinations committee for data science and AI has assessed the work of Peter Elmers. Dear candidates, you have all passed your examinations and therefore you will be conferred your degrees for the Master of Embedded Systems, Computer Science and Engineering, and Data Science and Artificial Intelligence. This degree entitles you to use the titles Master of Science and, if you wish, also the Dutch title Ingenieur. Our program highly values personal contacts between lecturers and students. Therefore, I now invite our students to come forward one by one to be congratulated personally by your graduation supervisor, who will also give a short speech for you. So I invite the first supervisor and the first student to come forward to receive their diploma.
Yes. Yes. Dear Omar, first of all, congratulations by all means for this fantastic achievement. So you carried your graduation project at ASMPT, which is a company in general that makes machines for semiconductor chips. And they provide back-end machines for packaging, and this company actually originated from Philips in early 2000. And then currently it is headquartered in Hong Kong, and it has branches all over the world. And near Nijmegen, it has the research center where you have spent nearly 9 months of your thesis. And Dr. Mark Weiflet closely supervised your thesis during these days. And I was, of course, at TV, we weekly met on different occasions. So during COVID period, we have all heard about shortage of chips in various domains. And it is generally, greatly because of the shortage of packaging machines that these kind of companies produce. And ASMPT is definitely one of them. The throughput of these machines means how many chips they produce, how quickly, and that's very important for almost all the high-tech industries that we see near this region and all over the world. And this throughput is highly influenced by the control system that runs behind these machines. And Omar has worked on those control systems, and he tried to make them faster to improve the throughput of the machine. And how did he do that? Basically, he basically tried to run the control systems on FPGAs, which are very fast. And the FPGAs are often constrained by the resource, like flip-flops, DSPs, and to address that challenge, what he did is approximate the computing of the controller. And then the question is if the controller still works as it is supposed to work functionally. And in his work, he explored various possibilities of approximation, and it produced several results and many colorful plots. And it was very interesting work and lots of results, lots of discussions, and it has been a very wonderful and pleasant experience working with all these months. But it has started a while ago, actually. It is basically Omar started attending my course, Embedded Control Systems, and it was during the COVID period. And in fact, the COVID was about to start then. And he's a guy who attended nearly all lectures, if not all lectures. I believe it is all lectures. And not only that, in every class, he has so many questions, and I must compliment that the number of questions he asked me over this year is probably more than what all other students asked me in this whole period. So it is a compliment by all means. It shows how inquisitive you are, how you want to be clear about everything, and that really makes it interesting. And not only that, during these lectures, you know that in winter, 8:45, nearly half of the class, including myself, is sleepy. And Omar used to ask so many questions that nearly all of them used to wake up, including myself, which actually helped and made the class quite interesting. And basically, this momentum continued during his thesis, so he decided to work with myself and in a company called ASMPT, as I mentioned. And there, again, he was used to be very well prepared with nice presentations, with lots of plots, obviously, in the presentation, and with a very clear plan for future and what happened in the past. And that makes the meetings very interesting, because it used to give a lot of points to discuss, and he used to come up with very interesting plots. I used to ask several questions every week, and he used to patiently answer my questions. I think over this period, my experience and my compliment to him is about how he sees any scientific question or scientific problem, and the way he approaches the problem. And he tries to be clear about every small things, and he's very inquisitive, and he does not really be shy to ask questions, which I really appreciate. And what I also noticed and what I also appreciate is his great sense of humor. And it's always in these difficult meetings, he will come up with small jokes which will make it more lively, which I also appreciate. And I believe that these qualities are real qualities that would help him in his career by all means. And I strongly encourage and recommend him to develop these qualities and possibly grow these qualities in his future. And I'm sure that they will help you in developing as an engineer, as a human being in your future. Once again, I congratulate you for what you have achieved today. It's fantastic. And I wish you all the best for everything that you are waiting for your future.
Thank you very much.
Thank you.
photo.
Okay, dear Ragav, I'm so happy to see you here, and today I have the honor to give you the master degree of M&CS system program. Now, it was last year around the same time, or maybe in October, that you contacted me and saying that you have an offer from Alten Technology for doing your master project with them, and you said that you have they offer the possibility to select one of the two projects that they have. We discussed that with each other, and then at the end you decided to go for the project that was about localization using LoRa wireless communication. And you started the preparation work in this December last year, and then the project itself in February this year. So your project was to investigate the possibility of doing localization or ranging using LoRa devices. And LoRa is a low-power, long-range wireless communication for Internet of Things. And the idea was to get an estimate of the position of LoRa devices or LoRa sensors without using, for example, a GPS receiver, just with the wireless communication or packet exchange that we have between LoRa devices, sensors, and gateways. And to do this investigation, you needed to plan and perform many experiments, because the plan or the objective was to experimentally evaluate the accuracy, the precision of ranging and localization using LoRa. And since we are talking about long-range communication, you had to do experiments in which the nodes are apart from each other, for example, for a kilometer or so. And for that, you needed to do the experiment in an open field. You had a number of scenarios for your test, line of sight, non-line of sight, and these kind of things. And at the end, you you did most of the experiments in open field, very big area. And it wasn't the easiest partially because also we had a quite rainy summer this year. So it was difficult to find some time to do those experiments, because you also need to deploy some sensor nodes 1 kilometer apart from each other, line of sight, and also having your computer with you. And you needed to repeat those experiments to have reliable results. And these challenges at the end, you really did a good job, but this challenge actually left you, just a short time for really analyzing the data, which was a pity. But the experiment that you did was, very, very great. So the results of your project actually showed your dedication, your skills, and I believe you learned a lot during this project from the technical perspective and also for planning and the other skills. And I was really enjoying working with you, and also the company was happy about your work. And it was a great, I think, experience for both of us. So once again, to conclude, I would like to congratulate you for this achievement and wish you the best in your life and in your future career. Thanks.
Hi, Siva. Very happy to be with you today to celebrate this big achievement in your life. So, for your graduation project, you worked at a topic at the intersection between embedded systems and security, and that's why you worked in the security group at UE, also in collaboration with the Technology Innovation Institute in Abu Dhabi. Specifically, you worked on the design, implementation, and performance evaluation of a privacy-preserving protocol allowing drones to protect the privacy of their pilot while having the operation. If this will sound you as quite an elaborated project, to make it worse, SIVA also worked on actual devices, very constrained in terms of a variety of parameters, for example, computation, processing, communication capabilities, energy availability. It was quite a challenging project, and I was always honest with you at the beginning, we didn't have the full 100% guarantee that it would have worked, but you were always very optimistic about the methodologies, coming up with several strategies to manage all the constraints that you had in the problem, and in the end you really managed to deploy this solution on actual constrained devices, running a variety of experiments with all the methodologies you came up with, and also with very good results that aligned with all the requirements that we have in the specific scenario. So a very challenging project with very good results. So you worked very hard. Now you are gathering also the results of this very hard work, both with the graduation, this ceremony, and also the inclusion of your results in a submission to a prestigious international journal and venue. So congratulations once again, and best of luck for your future career.
Sorry, I have quite a few. Okay. So, hi, Caroline. I have the honor to give you this diploma, so congratulations. So you didn't do your master project with me, so you did it with Taniro Celebi, but unfortunately he couldn't be here today because he had some duties outside of TUE, so he asked me to actually read a speech for you that he wrote. So when I will say I in that speech, you should understand that it is Tanir speaking to you. So since we unfortunately never had the opportunity to interact before, so I will stick to his text. So, dear Caroline, you came to me last year and told me that you wanted me to supervise a graduation assignment at a company on IoT-based predictive maintenance of industrial assets. I was positive about it because IoT systems and predictive maintenance are in my field of expertise, and the topic sounded good. Then you disappeared for a long time, and I honestly forgot about our conversation. Then you came back, but you already started the project and made a lot of progress. That was really odd and never happened to me before. We immediately tried to catch up, and with some significant delay, I must say, you were able to produce a good master thesis on quality analysis of such systems. When I first met you, honestly, you came across as a very shy person. When I ask you a question of, can you do this, can you do that, I do not ever remember you ever answering with a simple yes. Instead, you said, I'm not sure. You just disappeared for a week, and then you were back with progress. This is what I liked very much about working with you. Not that you underestimate your ability, but that you are a person who takes action and follows up. You are a very pleasant person who is very hardworking, and I think I am really happy with the return on investment. I am also very satisfied with the work you have done together, we have done together, and I know that you will continue this good work attitude in your future career. Congratulations, and we wish you the best for what comes next. Hi, Andre. here comes the next speech. So this time, congratulations, Andre. Again, congratulations for completing your master's studies and for this diploma. So this time, I actually supervise your project. So I can say something in my name. So Andre has been working on a master project which is titled Partial Order Reduction for Schedule Abstraction-Based Response Time Analysis in Multiple Source Systems. So that's quite a complex title with a lot of barbaric words. So I will try to contextualize that a little bit for people to understand the depth of what you have been doing. So imagine safety critical or mission critical systems. So imagine a plane, imagine a car, imagine a production system. So when you are developing new software for those systems and before deploying them, you would probably want to check that they meet some safety requirements. And among those safety requirements, you have timing requirements. So making sure that the system will respond before it is too late to some events. And so we have been developing tools that allow to provide such proofs in our lab for quite a few years. However, when systems become more complex, they grow in terms of number of tasks they have to perform, or the complexity of the computing platform is increasing, you can imagine that it becomes more and more complicated to actually check that timing requirements are met for every possible execution scenario that can happen during the lifetime of the system. And that's where the work of Andre came in. So trying to identify techniques and develop methods that will avoid to check all possible combinations that can happen for events and actions, but rather focus on those set of execution scenarios that can actually endanger the timing requirements of the system. And Andre did that in a very successful way. He actually developed techniques that are far from straightforward, but are probably way too complex to explain here. So I would encourage you to actually, if you're interested by these kind of things, go to the library and read his nice thesis. So it has been a very nice work that we have done together, and we really enjoyed it. And not only me, but also Mitra Nasri, who helped supervise you. And it has also been recognized very much by the committee that judged your master project, since you were awarded a 9 at the end for your very nice work. So that has been very nice times that we spent together. Each time we were having a meeting, I was looking forward to the solution you would bring and the new insight you would bring to the problems we are facing. And I think that everyone who will work with you in the future will recognize all those nice qualities that you have of being dependable, reliable, and also your ability to come up with new, interesting solutions to the problems that are posed to you. So again, congratulations to you and the best for the future. One more. Congratulations, Vu, for your graduation. So I will try again, like I just did, to try to contextualize what you have done during your master project. So for those who do not know yet, Vu has done his master project in a company which is called Alten, which is located not very far from here, and that is working on many different topics. But his master project was in the context of the development of a robotic arm that was remotely controlled by a glove. And Alten had envisioned the application in the medical industry where you would have remote surgery, or in application domains where operators cannot actually go in the area because it is not safe to operate in this area, and therefore would use those robot arms to do the task instead. So you would expect that in applications where you have safety requirements, like in the medical domain, you would have something that is predictable in terms of behavior. However, one of the components that was used in development of that system was the robot operating system, or ROS in short, which is all but predictable in terms of timing requirements. So Vu came to me saying, okay, I started that project in Alten. I would like to make ROS more predictable. And we decided to actually take up the challenge and try to find a solution. And then came the actual biggest challenge that we face usually in academia, which is transferring some theoretical ideas into practice. And that's what Vu did during his master project. So we identified a nice solution that could help improve timing predictability when using the robot operating system, which was called the logical execution time. And the logical execution time is a very simple idea when you look at it in theory. It has very nice properties, but it also makes very strong assumptions that are not necessarily always respected in real systems. And so Vu identified all those issues and all those assumptions that would be difficult to meet, and then looked also at solutions that already existed in practice. And he was not the first one trying to integrate such an idea in the robot operating system. Others had tried before, and one of those companies that tried to do that before is Bosch Research. So it's not a small company. They have a lot of people that are very smart trying to do that. Unfortunately, what they came up with was all but compliant with the initial specification of the logical execution time. And then Vu actually succeeded to take their solution and completely modify it, propose some new techniques that would actually make it work in practice. And he proved that it could work in practice. He actually developed two different solutions for different types of system. And I believe that's a very great achievement. And that was recognized also by Alten, but it was also recognized by Bosch Research, who we contacted afterward. Actually, Vu contacted them. And they were very interested by the solution he developed. And they are ready to support it, to push it as one of the next extensions for the robot operating system that will be delivered in a few months. So congratulations, Vu, for all these nice achievements. And again, best of luck in the future.
Dear engineer Ivon, your journey towards the master's degree formally ends here today with this diploma ceremony, and hopefully you can look back at many interesting lectures and other learning opportunities that you had both at Fontes, University of Applied Sciences, where you started a couple of years ago on your bachelor's, and later at our university. While studying in both places, you actually also had various jobs in companies working essentially as an embedded engineer, the field in which you're also graduating today. It was therefore no surprise to me that you wanted to also perform your graduation project within a company. And at the end of last year, you started doing this project at Edge Impulse under the supervision of Arjan Kamphuis and myself. Edge Impulse, for those who don't know the company, creates machine learning tools to run AI and artificial intelligence algorithms on edge devices. Many of us have maybe heard about AI products like ChatGPT or Midjourney, as these are frequently mentioned in the media. But I think the real AI revolution will happen once these algorithms can actually run on edge devices and will be all around us. And that's exactly what companies like Edge Impulse are working on. If you look at programs like ChatGPT, they can use enormous amounts of power. They can just build a wind farm next to it, use lots of water for cooling. But all of that is impossible when you're looking at an embedded device which needs to run within a very strict power budget and also typically within strict timing constraints on a resource-constrained platform. When developing these algorithms for an edge device, very early on comes the question, not only do I functionally deliver the results that I need, but I can do it within the energy that I have available on this resource-constrained platform and still make my timing constraint. So that means we actually need models, basically machine learning models, AI tools, to early on predict the power consumption and the runtime of an application when running on a platform. And that's exactly where your work focused on. You built a number of machine learning tools, models, that can predict the energy consumption of an algorithm when running on an embedded device, using a little bit of information on the structure of the algorithm that someone designs, as well as some architectural information. And the fruit of your hard work showed to Edge Impulse that it's indeed possible to make use of, to create these estimates and to actually use them early on during the design process when someone is developing a new AI algorithm to run on an Edge device. Therefore, Edge Impulse actually asked you to stay on board with them and to join the company, and are now working together with you to actually get this embedded into their actual product. And I think that's very much an achievement that you can be proud of. And not many students see the result of their master project so quickly embedded and integrated into a real commercial product. This is definitely an achievement to be very, very proud of, and it's also a true testament to your engineering skills. You're an independent, committed, hardworking person who really always strives to make ideas come to reality, and you're also always open to discuss new ideas with anyone that is around you, and basically always trying to learn from these discussions. I'm sure that with these skills and this personality, you'll be able to become a very good engineer that will achieve many more achievements in the future. In conclusion, I would like to congratulate you once more and wish you all the best for the future.
Dear Sunda, it's a great pleasure that I stand here before you on this momentous occasions of your graduation ceremony. Congratulations for your great achievements. As your supervisor, I'm very proud of you, what you have achieved. So from the very beginning of your projects, you have demonstrated fully automation and also excellent communication skills. At the beginning, we already know the challenges of this graduation project. And yeah, your graduation project was not an easy one. You're trying to apply the machine learning to automate the PCB layout of power electronics circuits, which is very important for energy conversion applied in all energy domains. This is, I think, a very challenging domain, and actually you are one of the few pioneers actually start to apply the AI in this domain. And yeah, so this involves multidisciplinary research, but you tackled it head-on with well-thought and focused research, focused approach, and your hard work, dedication, and incredible technical skills really lead you to excel in your work. And I'm genuinely impressed by your creativity. You always, demonstrate a high level of professionalism, and so you find some creative ways to solve the challenge issues. Like we are missing the data, and in engineering domain, it's not like the other AI application. There's a lot of data applicable, and the key missing data put a lot of obstacles. So you find some nice ways to come up with solutions, and also I'm really impressed by the quality of work that you have produced. Yeah, so I'm confident this impressive competence will definitely prepare you forward in your future career. And as you start your next journey, I really encourage you to pursue your passion, to challenge yourself, and also trust yourself. I definitely believe that you can achieve great things in the future. Yeah, so In conclusion, congratulations again. All the best for your bright future ahead. Yeah. Yeah, thanks.
Arjan. Zo, beste Arjan, gefeliciteerd met het behalen van je Master of Science titel. Voortaan mag je door het leven als ingenieur. Je hebt er hard voor gewerkt. Je hebt je afstudeerproject gedaan in samenwerking met ProDrive. Daar was je al werkzaam. En intern hadden jullie een project bedacht. En mij leek dat ook wel een interessante. Het project gaat erover het automatiseren van kabeltesten. Nou, jullie maken grote apparaten, kleine apparaten, maar overal zit wel een kabeltje in. En waar mensen heel veel nadenken over alle elektronica, blijkt toch dat vaak een kabel ook een deel van het probleem kan zijn. Dus om te zorgen dat dat niet in zo'n machine terechtkomt, moet je van tevoren een degelijke test kunnen uitvoeren. Blijkt dat dat toch nog altijd handwerk is om zo'n test op te zetten. Er is een algemene testmachine, maar daar past de stekker natuurlijk niet in. Dat betekent dat er een printplaat ontworpen moet worden. Die moet goed aangesloten worden. Daar moeten de juiste connectoren op. En er moet een testprogramma bij geschreven worden. Nou, dat is best wel wat handwerk en ook daar kunnen dingen in fout gaan. Dus jouw taak voor je project was om die zaak te automatiseren. In principe, het is makkelijk uitgelegd, dus dan is het vast ook makkelijk gedaan. En dat valt tegen. Want er is niet altijd een stekker die op de printplaat gesoldeerd kan worden waar je stekker in past. Dus in sommige gevallen zul je daar zelf een nieuwe stekker voor moeten ontwerpen. Je hebt gekeken naar vanuit de ontwerptekeningen van stekkers een 3D-printversie te maken voor het passende stekkeronderdeel, zodat je die op een print kunt zetten. Je moest kijken naar hoe je de verschillende onderdelen die je nodig had op je print plaats kon geven, hoe dat die bedraad konden worden. En inderdaad, hoe dat je de zaak dan vervolgens ook nog eens omzet naar een testprogramma. Al met al een hele lijst met problemen om op te lossen. En je hebt laten zien dat je als persoonlijkheid toch echt een aanpakker bent. Je bent daar gewoon vol ingedoken en aan de slag gegaan. We hebben op een gegeven moment wel een beetje af moeten remmen om ook nog te laten zorgen dat het niet alleen een oplossing was, maar dat je ook inderdaad kon aantonen dat het een goede oplossing was en misschien wat er wel en niet beter nog kon. Maar dat heb je ook goed opgepikt. En uiteindelijk heb je een systeem weten te ontwerpen wat geautomatiseerd inderdaad een voorstel kan maken om zo'n print, inclusief het hele testsysteem, te genereren. En ProDrive, begreep ik, was er erg gelukkig mee. En in je huidige werk ga je er alsnog aan verder. Dus wat dat betreft, goed werk geleverd. Een bruikbaar resultaat. Ik wil ook graag Martien Spierings nog bedanken. Dat was de medebegeleider vanuit ProDrive. Die heeft je natuurlijk ook van veel advies en support kunnen voorzien. Dus goed werk geleverd. En heel bedankt voor alle leuke gesprekken die we ook gehad hebben tijdens je project. Dus van harte nogmaals gefeliciteerd en heel veel succes in je verdere carrière. Ja.
So dear Philip, dear engineer Zamfirov, congratulations on successfully defending your master thesis and obtaining a master degree and engineer's title, which is a laudable accomplishment. So we started talking roughly 1 year ago when Dennis Dams, a colleague from TNO, who is also here present, has contacted me, and actually Dennis didn't even told me anything very specific about you. He just said, I want a copy, a preprint of your article that you have recently published about log analysis, because apparently there is a student who is interested in this stuff. Well, I thought, sure, good. And then the student turned out to be you. And I actually knew your name because I noticed it that on the list of supervisors of the undergraduate projects. And for me, it's a clear sign of maturity. So I was extremely excited when it turned out that you decided to work on your master project under Dennis's supervision and mine supervision. So the project was quite complicated because it involved working with TNO and with the university for Philips. So already this combination was far from being trivial. And essentially you have even started doing something that most of our students don't dare doing. You have started talking to people. Computer science students don't like people. They are scared of them. And Philip had not only to go to people, but also ask them all kinds of horrible questions. Like when you are looking at those logs, what they're actually looking at. How do you realize that this is where your bugs are? So this was far from being trivial. So essentially, based on your interviews, you have identified a series of structures that developers believe to be important for bug finding in the logs. But this was only one part of the story, because as befitting a software engineer, you also have built a tool. But you didn't build a tool yourself. Actually, it was even worse. You have taken an existing tool and started building stuff on top of it. And as every software engineer here in the room knows, so this is even more complicated because you need to figure out what the existing software does and why it doesn't do what you want, right? So this was the next challenge. But this was also not the end of the story, because then you had to evaluate whatever you have implemented, because it's cool that you implemented it, it's cool that it's somehow related to the interviews, but who knows whether it will actually help. So you went back to Philips and you asked people to actually use the tool, not even telling them that it is your tool, so that it will be objective and not influencing. And surprise, surprise, they actually managed to find bugs using your tool. So now Philips is happy because they got a tool. Dennis and I are happy because we got a great student, and we have even submitted a conference paper based on this experience. So congratulations, and let me also use this opportunity to welcome you to our research cluster as a PhD student. So I'm looking forward and wish you to seeing you working with us, and lots of success with the continuation of your scientific career. So dear Peter, congratulations. You are the last of this series of graduates, but definitely not the least by any standards. It's a great pleasure for me to reflect on the trajectory, the way you went through. So you sent me an email on November 14, which is almost day to day, 1 year ago. And essentially, you've been saying that you worked at Facebook, Meta, before coming to Eindhoven, and that while working there as a software developer, you have learned a valuable thing, not to trust comments. Because while source code comments are supposed to help people to develop software, for gazillion of reasons, they're getting outdated. Somebody has modified the source code without modifying a comment. Somebody has copied the source code without copying the comment. Somebody has missed something or misinterpreted something. So for all those reasons, the tool which is supposed to help you to understand software actually becomes counterproductive. And it makes your life even more miserable as a software developer. So this was where you have decided to intervene. You have decided to start by building a tool that, given a code fragment and the corresponding source code comment, would tell consistent or not. useful to understand this particular source code fragment, or not? You know, you are not the first one to look into this area. Recently, there is a conference article published at a very important conference, AAAI, about this topic. We thought, sure, not a problem. The only issue was, you know, they've been working with Java. We wanted to work with more programming languages because, of course, you know, the world is not limited to Java. Sure. So first of all, things which worked for Java turned out not to work for any other programming language. Second, it turned out that the things which were supposed to be working for Java didn't even work for Java. And this is because, for unclear reasons, in 70% of the non-consistent cases, the snippets included 2 new lines in the end. So the machine learning classifier was successfully learning those new lines, but nothing else. The moment, the moment Peter has removed those new lines, all the performance just gone. And it went like from 90% to 10%, 15%? 60? Okay, 50 would be guessing, right? You know, we are guessing. So, yeah, this was kind of frustrating. And then we thought, well, maybe we are solving a wrong problem. So Peter has submitted a number of manually crafted examples to open source projects to see whether essentially indicating that those comments are not consistent would be beneficial for them. And surprisingly, almost all those changes have been integrated, clearly indicating that there is a need, but at the same time there are no solutions. So there is a huge gap when it comes to ensuring consistency of code and code comments. So this was a starting point for hopefully a number of continuation steps we are going to make. And similar to the work of Philip, we have also submitted your work to a conference. So let us hope it gets accepted and gets seen by the community. And hopefully, with our help and help of some other researchers, we can help software developers to accomplish their tasks in a less painful way. I would like to congratulate you again and wish you lots of success for all your future endeavors. Sure.
So this was the last speech for a candidate, but not yet the last speech, because the department has a very active study association, GEWIS, and on behalf of GEWIS, Laura will now give a speech.
Yes, thank you. Dear graduates, dear family and friends and supervisors, Professor Mark already introduced me. My name is Laura and I'm the current chair of GEWIS, which is the Study Association for Computer Science and Mathematics Students here at TUE. Today can be marked as a very important event for technological development, and that is that you're receiving your diploma. That means that you're officially out of the doors from the TUE. And I hope that a bright future is waiting for you, perhaps as a PhD student or with a job in a company. Of course, I want to express your congratulations on behalf of GEWIS. You should recognize how much effort and time you put into obtaining this diploma, many late nights of studying, and I hope you also had fun somewhere along the way. And I hope that GEWIS could also be there for you, perhaps with some activities for education, career, or as just a place of community where you can connect with some students. And I hope that you recognize now the responsibilities that come with this degree. But if you think that you're going to miss your student days somewhere along the lines, I hope that you join ADA, which is a Alumni Association, and reconnect again with some peers from back here. And yeah, only thing that is here left to do is once again congratulations. I hope that you have a very bright future, and I wish you all the success in your future career. Thank you.
Dear Masters of Science, with reference to the words of the previous speakers, and on behalf of the Department of Mathematics and Computer Science, and also on behalf of the Department of Electrical Engineering, I would like to congratulate you and your families on your degree. I wish you every success and good fortune in your future career. before we actually start celebrating, I still have a few serious words to add, because your academic title also comes with responsibility towards society. And therefore, I will now read out the Code of Conduct. The scientific degree of Master of Science involves duties as well as rights. As a holder of this degree, you are committed to standards of scientific integrity, trustworthiness, intellectual honesty, openness, independence, and societal responsibility. These standards are described in more detail in the Netherlands Code of Conduct for Research Integrity and in the Eindhoven Code based on it. You also have duties towards society. You must be clear about the boundaries of your own expertise, and you must communicate honestly and independently about the results of your work, including potential risks associated to it. And you're committed to the ethical codes for research and design. So this almost concludes this session, but let me mention that our photographer is now going to take a few pictures of the candidates, maybe with the committee also. So yeah, for the audience, you're kindly asked to leave this room, and upstairs there will be drinks for you, and wait outside until the candidates come up, and then you can congratulate you. And thank you for joining this ceremony, which I hereby close.